All right, so let's keep going with our average value and everything here. Find the value of C guaranteed by the MVT for integrals for which this function on this closed interval, okay, interpret graphically. So we should probably get a graph. X squared plus 1, that's just x squared moved up 1. All right, and so we're looking on this interval from -1 to 2. Oh, that looks about even. Let's go to 2. There we go. All right, so we're looking for some C value, all right, or some X value. It doesn't matter, however you want to think about it, where the area under the curve from -1 to 2 is equal to the area of that rectangle that it makes. All right, so we're trying to find something to do with this area. So we're going to find the average value. Okay, so the average value equals, remember it's 1 over, and you should write this out, show what you're doing, don't just write 3. Okay, the width times that height, but we don't know how to find that height. So we get the accumulation from -1 to 2 of our function. And this is a simple integral that we can do 1/3 times x plus 1/3 x cubed evaluated from -1 to 2. So we get 1/3 times 2 plus 8/3 minus -1, okay, minus 1/3. So I think adding that up, 2 plus 8/3, so 1/3 times 2 plus 8/3, that'd be 6/3, 14/3 minus, and that's 1, so -4/3 plus 4/3 be 18. 1/3 equals 18/3. So 6, 1/3 of 6, which is just 2. All right, 2. So what that's saying here is that the average value of the function, the average y value, remember, y value of the function is just 2. All right, so then where does our function equal to? So 1 plus x squared, where does that equal to? Well, x squared equals 1, x equals plus or minus 1. So let's make sure both of those answers make sense. Right? So that means if -1, that means that the area of this rectangle would equal the same the area as the whole under that curve from -1 to 2. And so we have that height at 1 or -1. Now it can be on a closed interval, so that is our answer. X equals 1 or x equals -1. Okay. This one show that the average rate of change of a car's position over a time interval is the same as the average value of its velocity function over the same interval. All right, so if you were going to find the average rate of change of a position function, and you could call S of t or x of t, it doesn't matter. And cars usually travel, right, miles in a certain amount of hours. So let's say we have a function, here we go, that's the car, it's going so many miles over so many hours, and we're going from T1 to T2. So the average value from, say, here to here, that's just going to be S of T2 minus S of T1 all over T2 minus T1. And again, that's our average value. So looking at it in another way, if we look at velocity this time, now remember, velocity would be like miles per hour over hours. Let's say, yep, we have some weird function, who knows, T1 to T2. And let's see, if we wanted to find the average velocity over that time, we would do 1 over T2 minus T1 times the integral from T1 to T2 of our velocity function. All right, but let's evaluate that. So 1 over T2 minus T1. The integral, if we integrate velocity, we're going to get position. And if we evaluate it from T1 to T2, we're going to get on top of our fraction here, s of t2 minus s of t1 over t2 minus t1, which is the same exact thing that we got before. All right, so that's important. So if we're given a position function, we can find the average value just by showing that difference quotient. Okay, and if we're given a velocity function, we don't have to find the position. We can just go ahead and analyze that. All right, so this is a pretty good example that shows us both uses. All right, so we have a continuous function on some closed interval. So we can use the MVT if we need to. Find the arithmetic mean of f of x. All right, well, the arithmetic mean, that's pretty easy. Of course, you remember that. You just add up all the values. 42 plus 38 and divide by the number that you have. 31, 29, 35, plus 48, plus 60, and I think all divided by 7, if I counted right. And I believe you should get 40.428. All right, that's the easy part. And now use a trapezoidal approximation. All right, so the average value of f from 50 to 20, so we do 1 over 50 minus 20, times the integral from 20 to 50 of f of x dx. And we can approximate that by doing 1 over 30 times, now we're going to do trapezoid, so 1/2 times, and if you look, all of these are going up by 5, so we can pull out that 5. Now for the trapezoids, remember you're just taking the first and the last one and 2 times all the middle terms. I'm almost done writing it down. Oh, not the 2 for the 60. There we go. All right. So add all that up in your calculator, and you should get about 38.886. So it's kind of close, right? And so if you have a choice for a more accurate one, you probably want to use the trapezoidal, because remember that kind of matches our curves really well, where the arithmetic mean is just picking out random numbers here. All right, and this here, sometimes we might have to solve an integral equation. How exciting. All right, so we're going to have to simplify them. And here are a couple of examples showing an important application that is important. So it's very important, so we might as well do it. Find the number b, or numbers. So it's the average value of that function on that interval is equal to 3. So let's say the average value, 1 over b minus 0, of this function. So we're accumulating from 0 to b, and the average value is equal to 3. All right, so we have 1 over b. Let's integrate this. 2x plus 3x squared minus x cubed evaluated from 0 to b, and this equals 3. I don't want to have to keep writing that 1 over b, so I'm going to put it on the other side. Okay, so times b times b. So now I'm going to evaluate. So I get 2b plus 3b squared minus b cubed minus 0. Nice. Okay, equals 3b. All right, so I have 2b plus 3b squared minus b cubed equals 3b. Put everything on one side. I like everything to be positive, so minus 3b squared plus b. We're trying to figure out where that's 0, so that would be, we could factor out a b. All right, so that would be b equals 0. That's on our interval, but is our average value going to be equal to 3 here? No, that's kind of irrelevant. All right, so now we have to solve this equation. Aha, quadratic formula, our favorite. So b is going to equal the opposite of b, so 3 plus or minus the square root of b squared minus 4ac all over 2a. So 3 plus or minus the square root of 5 over 2. Now we just need to check that both of those are in that interval. And it turns out that they are, because square root of 5, that's going to be 2 point something. So we have two answers, 3 plus square root of 5 over 2, or 3 minus square root of 5 over 2. So a pretty good problem there. This one, I think these two are neat. You might not. I'm going to pick, I'll do one, and we'll finish the other one in class. If you want to try it, it'd be great. I'd be really happy if you all came in with the answer, but you know, you don't like to make me happy, so it's fine. Solve this conditional equation for the indicated variable. All right, so let's just think about this for a second. We already know an answer, whether you know it or not, you do. If this is giving us the approximation for, you know, area, but if it's over the curve, so where is that going to equal 0? Well, one obvious solution, hopefully, is -5. Because if you integrate from -5 to -5, you're not going anywhere. That's just going to be equal to 0. So there's one solution to the equation. Now, another one, which might not be so obvious, but it should be, what kind of function is this? Hopefully you know that that's an odd function. Right? So if you have an odd function, so let's say something like this, right? This is odd. Well, if I drew it right, this would be odd. If you integrate from, let's say that's -5 to 5, these kind of cancel out, right? Or what sign's odd, so we could think about it that one. If you integrate from -2 pi to 2 pi, it's just going to be 0 because they all cancel out. So another intuitive answer is 5. So maybe we have them all already. All right, or maybe we don't. Now we got to actually do some algebra here. Not calculus. Notice I said that. We'll do a little bit of calculus with a lot of bit of algebra. All right. So integrate. 1/4 t to the 4th minus 7/2 t squared, evaluated from -5 to x. Okay, this looks like a fun one. X to the 4th minus 7/2 x squared minus 1/4 times 625 minus 7/2 times 25. All right, and remember this is going to be equal to 0. So I'm going to simplify. I'm sure you guys don't like fractions, but wait, let me rewrite it a little bit more. Okay, 7/2 x squared minus 625 over 4 and minus, what would that be, 175, I believe, over 2. All right, you hate fractions, so let's get rid of them. Multiply everything by 4. All right, x to the 4th minus 14 x squared minus 625. Oh, I forgot to change my sign there. Plus 350 equals 0. All right, I'm going to just continue over here. So now x to the 4th minus 14 x squared minus 275 equals 0. Maybe that factors. I'm not going to play around because I know there's a lot of factors of 275. But we already know something. So if we already know two answers, hopefully you already know what we could do. We can use synthetic division to make this easier. We already know two values. Oh, I almost did the terrible mistake there. So 1 x to the 4th, 0x cubed, negative 14x squared, 0x, negative 275. All right, let's do synthetic division with 5. 1, 5, 5, 25, 11, 55, 55, 275. Whoa, look at that. Now let's do -5. 1, -5, 0. Oh, always a good number. 0, 11, -55, 0. Great. So now we have x squared plus 11. Could that equal 0? Oh, it can't. So we did all this work basically for nothing. These are the only two answers. All right. And if you look at the graph, you kind of get that idea. And so I'd love for you to try example or part B. I'm sure you're not going to. If not, we'll do that one in class. Okay. Have a great day.